Now that we can recognize some characteristics of exponential functions, we can now graph an exponential function. There's this example. We have graph f of x equals 3 to the x. Now, by evaluating at the values -2, -1, 0, and 1, we obtain these points, -2 and 1/3, or 1/9. We have -1 and 1/3, 0, 1, and 1, 3. And we can plot these points on our graph and connect them with a smooth continuous curve. Now we should recognize that there is a horizontal asymptote so that it approaches the x-axis but does not get there. It gets very, very close, and then it continues and is increasing because our base is 3. Now let's look at a few other examples. Sketch the graph using rules of translations and reflections. H of x equals 2 to the x minus 4. For this one, I'm going to begin by creating a table. So -2, -1, 0, 1, 2. And because I'm going to actually find points for 2 to the x, not 2 to the x minus 4. Well, 2 to the -2 would be 1/4. Again, because we have a negative exponent, we have the reciprocal. 2 to the -1 would be 1/2. 2 to the 0 is always 1. Anything to the 0 is 1, as long as you're not 0. 2 to the 1 is 2, and 2 to the 2 is 4. So our points we have are -2, 1/4, -1, 1/2, 0, 1, 1, 2, and 2, 4. Now, because we are, well, with this function, we are shifting, we are translating our function down, 2 to the x minus 4 would become, instead of 1/4, that would be 1/4 minus 4, which is -15 over 4, or -3.75. So that's a point we can plot. -2, -3.75. All right. For the second point, we would take 1/2 and subtract 4. Be at -3.5. So -1, -3.5. Not much bigger. That'll be -7 over 2 as a fraction. Now, for the next point, we'll take 0, 1 and subtract 4 from the y-coordinate to get -3. So 0, -3. And we'll next take 2 minus 4, it'll be -2. So that would be the point 1, -2. And 4 minus 4 would be 0, so that we have the point 2, 0. Now you can see that our horizontal asymptote has shifted down 4 because our function was shifted down 4. So I'm going to go ahead and draw that here. We now have a horizontal asymptote at y equals -4. And we'll connect those in that fashion. Again, looking at the shape. Right, for our next function, we have 5 to the -x plus 2. So our horizontal asymptote should be up there at +2. We can go ahead and say that. +2. And 5 to the x, let me go ahead and make a table. X and 5 to the x would be at -2, that would be 1/25. At -1, that would be 1/5. At 0, that would be 1. Again, they have the same y-intercept. At 1, that would be 5, and at 2, that would be 25. So those are some points we have. Now, the 5 to the -x is going to change the signs of all of these. I'm just going to modify this. I'm going to change this to 5 to the -x, and my x-coordinates will now be +2, +1, 0, -1, -2. Then I can add 2 to all of those. 5 to the -x plus 2. Let's take those. So starting at the bottom, that would be 27 from 25. Y value of 5 would become 7. The y value of 1 would become 3. 1/5 would be 2.2, or 11/5. And 1/25 plus 2, 2.04, or exactly 51/25. So let's plot those points. All right. Let's see. -2.27. Okay, I can't plot that point. But -1.7. I've got the point 0.3. I have the point 1 and 2.2. I have the point positive 2 and 2.04. Okay. My values are approaching the line y equals 2, which is our horizontal asymptote. So I can connect these in a smooth curve approaching my asymptote. So what I could have observed is that this negative x is an exponent, 5 to the negative x, is a reflection. It's a reflection across the y-axis. So instead of increasing, as this one does, this function decreases towards the asymptote. All right. Our next function, maybe we should notice that. This one, we have a negative out here. This affects the y values. So this should be a reflection across the x-axis. So if I begin with my points, x3 to the x, -2, 3 to the -2 would be 1/9. 3 to the -1 would be 1/3, so I have the point -1, 1/3. I have the point 0, and then 3 to the 0 is 1, 0, 1. The point 1, and then 3 to the 1 is 3. X equals 2 would indicate that we have y value of 9. Now, if we change the sign of the y values by making that a negative, I now have -2, -1/9, -2, -1/9, just above 0, or below 0, -1, -1/3, same vicinity, 0, -1, I have 1, -3, and I have 2, -9, which puts our horizontal asymptote on the x-axis. I'll go ahead and connect these in a smooth curve, and there is our graph. All right, the last graph we have is f of x equals e to the x plus 1. Now, from our transformations, a plus 1 inside of our function, that's what we have as an exponent, is shifting to the left 1. So the function e to the x, let's start out with a table for e to the x. We take -2, -1, 0, 1, and 2 as our x values, which would mean we have 1 over e squared, 1 over e for -1. 0, 1 is a point we have, and then we have 1 and then e to the 1, that would be e, and 2, and the y value is e squared. E squared is about 7.4, e is about 2.71828. Now, what we changed, we're shifting this to the left one, so our x values change. So my -2 as an x value would become a -3. My -1 would become a -2. My 0 would become a -1. My 1 would become a 0. My 2 would become a 1. So I have these points, -3 and then 1 over e squared. 1 over e squared is 0.1, so -3.1. -3 and then positive 0.1. Now we have the point -2, 1 over e. 1 over e is 0.36 about. So -2.36, still in that same vicinity. We have the point -1, 1. So our y-intercept was shifted to the left one. We have 0e, so that's 2.71828. We have the point 1 and then 7.4 thereabout. 7.4, we see that our horizontal asymptote does not change. It is still y equals 0. Now we'll connect these with a smooth curve, and there's our function.